This video is for Math 70, and this assignment is on solving inequalities. And these work a lot like equations, very much like equations. It's a lot of the same processes, one important difference though. So let's talk about that important difference. In an equation, the equal sign indicates that the two sides are the same, okay? And so if you say x equals 5, or 5 equals x, exactly the same statement, okay? Now, greater than and less than signs, well, first off, let's talk about the symbols themselves. This is a greater than sign, and then you've also got the greater than or equal to sign. And this is the less than sign, and this is the less than or equals to sign. I'm always surprised at how many people can't figure out a way to tell one from the other. It's an important distinction, okay? These symbols tell you which of the two things is bigger. Now, I can tell you that in the history of mathematics, the mathematician who developed the equal sign said that he chose two congruent line segments because what could be more equal than two equivalent line segments, okay? Now, this next part is just something that occurred to me in looking at these line segments. If you squeeze down on this side, right, so that these get closer and closer together, and that opens up this side, that means that this side will be smaller and this side will be bigger, okay? A lot of teachers like to tell stories about alligators eating numbers and so forth. That's fine. If that helps you to remember it, I have no problem with that. I like to stick with mathematics, so if we say something like x is less than 7, right, this side is squeezed down, this is the smaller quantity, this side is open, bigger, this side is the bigger quantity, okay? Alright, so there are the greater than and less than symbols. Now, remember what I was saying over here, where because the two sides are equal, it doesn't matter which side they're on. X equals 5, 5 equals x, they both say the same thing. Over here, this one says x less than 7. Now, if I swap sides, and I say 7 less than x, now I'm saying the opposite, okay? I wrote it in a different color because these two things say the opposite of each other, all right? So it makes a big difference which side of the inequality a number or a variable is on. In an equation, it doesn't make any difference. Okay, why am I talking about this? The big difference between equations and inequalities is that if you're solving an inequality, let's say you've got something like 2 minus 5x less than 12. Okay, we'll keep it simple. This minus sign, remember, is attached to the 5. This is a positive 2. If we want to move it to the other side, we've got to subtract 2 on both sides. This will be negative 5x less than 10. Here's the trick. When we go to divide on both sides by negative 5, these cancel out. This will be x. Over here we'll get negative 2. But we flip that sign. Anytime that we divide or multiply by a negative number, that's going to flip this symbol around. Why? Okay? Well, let's look at the same problem, but instead of leaving that negative 5x where it is, let's move it to the other side as positive 5x. Okay? And so then that'll cancel out. This will be 2 less than 12 plus 5x. Then we'll subtract 12 on both sides. Negative 10 less than 5x. Divide on both sides by 5. X greater than negative 2. Okay? So that's the thing, is that if we do this without multiplying or dividing by a negative, if we get that negative out of there by moving it to the other side, now we're switching which side of the inequality the variable is on. Okay? And like I just said, that makes a big difference. Which side of the inequality you're on makes a big difference. So, if you multiply or divide by a negative number, it's as if you have switched sides in the inequality. That's why this thing has to flip around. Okay? So, I understand that's a little bit tricky, but there's a reason why it happens, and it's a good thing to remember how it works. Okay. Before we get started with some sample problems, I just want to talk about one distinction here. Let me put two problems up here. Let's say maybe x over negative 2 greater than 7, and let's say x plus 3 less than 9. Okay? Over here, to clear out this negative 2, I want to multiply on both sides by negative 2, and that'll flip that around and make it x less than negative 14. Over here, I'm going to subtract 3 on both sides. Now, sometimes people see this negative sign and say, oh, I better flip this around. Nope. No. Because only when you multiply or divide by a negative number is when you flip that around. Here, we're subtracting. Makes a big difference. This stays the way that it is, and we just get x less than 6. Okay? All right, let's look at some sample problems. Okay. Well, let's start with problem 4. We've got 6 minus 4x less than or equal to 10. And, oh, also, it's good to understand how to graph these on a number line. So I'll start doing that once we get some answers here. Again, remember, this negative sign is attached to the 4. This 6 has a plus in front of it. If we want to get rid of that 6, we're going to have to subtract, and that negative sign stays with the 4x. Now, we didn't multiply or divide by a negative yet, so that stays the same. This will be 4. Now we are. We're going to divide by a negative number. That's going to flip this around. Okay? These cancel out, and we get x over here, negative 1. X greater than or equal to negative 1. We want to put this on a number line. There's 0. There's negative 1. We color it in, okay, so that the circle includes negative 1. And then just show clearly some indication that all the numbers that are greater than negative 1 are included as well. Okay, that's problem 4. Let's look at problem 6. We've got 2x minus 8 greater than 19. Okay, so let's add 8 to both sides. 2x greater than 27. Divide on both sides by 2. And this will be, what, 13.5. Okay. And you don't have to get too detailed on your number line here. Just give me a 0 so that we know which side of the 0 we're working on. And then if there's only one endpoint, then that's all we're going to need besides the 0. Okay, because it's only greater than, we put an open circle around the 13.5. Okay, and then everything that's greater than 13.5 is included, but not 13.5 itself. And that's the difference between greater than versus greater than or equals to. Greater than or equals to includes this boundary point. The greater than does not include the boundary point. Okay, so let's look at a couple more here. Let's see. Well, let's skip down to problem 16. And these are a little bit more complicated. So, 16, we start out with 5x minus 8. Less than or equal to 3x plus 7. Okay. Now, if I look at this problem for a minute, I can see these are both positive, so I'm going to have to subtract either one to move it to the other side. So I'm going to choose to move this one over here because when I do 5 minus 3, I'll have a positive 2, and then I won't have to worry about flipping this symbol. So let's do that. Minus 3x, those cancel out. This stays the same. Over here we'll have 2x minus 8. So now let's add 8 to both sides. 2x less than or equal to 15. Divide on both sides by 2, and we get x less than or equal to 7.5. Okay, so this will be colored in, and then we want everything less than 7.5. Okay, let's see here. What else? Well, let's take a look at this one. What if I had moved the 5x to the other side? What if I did it the other way? We should still get the same answer. So 5x minus 8 less than or equal 3x plus 7. So if I subtract the 5x on both sides, don't lose that negative sign with the 8. That'll be negative 2x. Subtract 7 on both sides. Negative 15. Now remember, I haven't multiplied or divided by any negatives, so this thing stays the same up until this point. Now I'm going to divide by a negative 2. This thing's going to flip, and this will be x less than or equal to 7.5. There we go, we get the same thing. Okay. Now let's look at a couple more here. Let's see. Problem 20. We've got 7 minus 8x greater than or equal to 5 minus 7x. So in this one, both the 8x and the 7x are negative, right? So if I want to move one to the other side, I'm going to have to add it. So I'm going to choose to add this one over here, because when I do, I'll end up with a positive x. Okay, so there's the 7. That stays the same. 5 plus 1x. And you don't have to put the 1 there if you don't want to. And then we'll subtract 5 on both sides. This will be x. That stays the same. X less than or equal to 2. So there's our 2 less than or equal to, and then everything to the left of 2. Okay? All right. Let's see what else we've got here. Well, let's look at problem 24. So 18 plus y greater than 9y minus 12. Excuse me. Okay, so in this one, both of these y's are positive. This is positive 1y, this is positive 9y. If I want to move them, I'm going to have to subtract. So I'm going to subtract this one. Minus 1y, minus 1y, those cancel. This stays the same. 9 minus 1 is 8y, and then the minus 12. Okay, so let's add 12. Then we'll have 8y, this will stay less than, and that'll be 30. Divide on both sides by 8, and what do we get there? 15 over 4, it looks like. Now you can do that on a calculator, and it looks like it'll be 3.75. Okay, 3 3/4. So y less than 3.75. And no equals to on there, right? So we have an open circle. and everything less than 3.75, right? Remember, this side has the bigger opening, so this number is bigger, all the y's are smaller, and that's what this number line shows. Okay, so that's it for the introduction to solving inequalities. In the next assignment, we'll look at what are called compound inequalities, and that's where we have kind of two inequalities at once, but we'll save that for the next assignment. As always, if you have any questions about this, please let me know. Thank you.